Good afternoon, and thank you for the organizers, Jason and others, to invite me to give a presentation in giving you an overview over what we've been doing in CCRS. And I also want to thank Winston to provide this excellent context with IPCC and the Working Group 2 and 3 work that's been going on. So I'll take you on a journey of, let me see how this works. I'll take you on a journey to understand a little bit of the physics of the Earth system, as well as what we've been seeing as a result on doing the climate change projections. The key message I want to leave you with, and I'll say this at the very beginning following Winston's example here, is CCRS has this absolutely unique data set to share with the region. And we invite collaborators to come, use our data, analyze our data, work with us, and we're open to share. The data is free. We're just about to build a data sharing portal, but in the meantime, we'll work with you. So especially whether it's around heat or other topics on climate change impacts, at the moment, this is probably the data set you want to have a look at. Okay, so let's start. I usually start my presentations these days by emphasizing the role of Southeast Asia and the maritime continent in the Earth climate system. So we are in a location which is called the heat pump of the climate. So in the redistribution of the sun's energy between the equator and the poles, the energy is being moved towards the higher latitudes on both hemispheres. But the biggest heat pump is here in Southeast Asia. And this is one of the reasons why the climate is so extremely active on all timescales. And this infographic is there to show you what sort of what we call climate drivers are driving, especially temperature and rainfall variability in our region. So the two lines in red and blue are the key northern and southern lines of the monsoon that migrates every year between the northern and the southern edges. You'll see the flows that are coming with this. So currently, for example, we're in the northeast monsoon flow. You see some cooler breezes out there and giving us a bit of a cooler temperature in Singapore. And so this is on seasonal and annual time scale, one of the key processes. On shorter time scales, we have drivers like the Madden-Julian oscillation, bringing enhanced rainfall propagating from the Indian Ocean all the way through to the Pacific Ocean. We have the key ocean atmosphere interactions in the Indian and Pacific Ocean that are called El Niño Southern Oscillation in the east and the Indian Ocean Dipole in the west. And they're bringing us key drought and enhanced rainfall periods depending on which phase that they're in. We have the tropical cyclone away from the equator that provides some extreme weather events to the region, as well as specifically for us in nearby are these what we call the Sumatra squall lines that are very fast-moving rain systems that are coming across. So at all time scales, we have processes that drive our weather and climate. And if you look at climate change, you also need to understand what happens to those key variability processes for us. So what I want to do is talk to you through what we did in our national climate change study based on IPCC's global climate model of the latest assessment, and show you some of the key results, especially when it comes to impacts. So alongside the IPCC cycle in the background is actually a second cycle where all the research scientists in atmospheric modeling built the latest atmospheric global climate model and run it on absolutely defined standard experiments. These are called the coupled model intercomparisons, and alongside the AR cycles of IPCC are the CMIP cycles of the modeling community. And whatever they produce, the scientists analyze, write the papers, because IPCC, as we know, is not doing the science and research. They're only assessing the science. They're not allowed to do the science, so what will happen is the science community writes up their results, and IPCC writes about the key results and produces their assessment reports. So for us, the key is actually the cycle on the modeling, because we take those, they're called, many people call them AR6 models, but they're actually called CMIP6 models. So take these global models, and because there are two cores, we need to downscale them to resolutions that matter. The resolutions that matter for the entire Southeast Asia region, and resolutions that matter for Singapore, for example. And so, what we did is we used the CMIP6 models and downscaled them to resolutions using 3 out of the key IPCC scenarios. So representing the low pathways of sustainability, we chose the SSP 126, the middle of the road SSP 245, and the business as usual fossil fuel development, taking the highway SSP 585. So, and after a significant extensive model evaluation of those CMIP global models, we decided that there were 6 models that were sort of the most skillful in Southeast Asia, and those 6 global models, we downscaled them. And we downscaled them, as you can see on the top right there, over the, 2 of these blue frames. So the outer frame, the large Southeast Asia frame, is we downscaled the models down to 8 kilometers. And then we further downscaled those into the more narrow frame onto 2 kilometers, providing for the very first time actually information across the Singapore island, where you could see differences between the east and west sides in terms of future changes of temperature and rainfall. At the same time, we also updated the sea level rise projections from IPCC for the 6 tide gauges in Singapore that had long enough records. But we also looked at the regional tide gauges, and I will show you a few of the results later on what we saw in sea level rise across the region. As I said, we're building a data sharing portal. We already built a data visualization portal, and the QR code is later on, where you can explore thousands of these images from our study. But if you're after data, contact us or wait for the data sharing portal to open up. Some of the key results, and as I said, this is only a brief sort of walkthrough, as I won't have the time to show you everything here. First, rainfall. So we know in Southeast Asia the rainfall on mean annual changes is increasing, but it doesn't really tell you much of the story in the different regions in Southeast Asia, because we know the key information that is important here is A, on seasonal timescales for the different seasons, and B, in terms of the extreme events. So for example, here we have the analysis of what's called RX1 day. What is the annual maximum one-day rainfall that may occur in future? And we see across Southeast Asia some really significant increases on these annual maximum one-day rainfall. The other extreme that is often showed here is what is the annual maximum 5-day rainfall, and here, for example, you can see a plot as well. But again, the key results here are the seasonal changes are quite different across the region, and here's a figure for the June, July, August period where you can see some 50 to 90% increases over most of Southeast Asia. On the flip side, when we look at the dry spells, here I just picked one figure at the warming level of 4 degrees in the future, where you can significant increases in the average annual maximum dry spell length expressed in day. So we see the rainfall is increasing in stronger events, but also with larger periods of dry spells in between. Going to temperature, which is more relevant for this forum. So one way is you can just look at the temperature and not as at heat itself, which usually involves humidity and wind and radiation as well. So just looking at temperature, we look at the change in what's called the daily maximum temperature, and we can see some significant increases across the region, breaking the 5-degree barrier in some of the countries in Southeast Asia. There clearly are hotspots in changes of the daily maximum temperature, but in general, the increase as expected also scales with the emission scenario. The key message here is hot days are to become the norm. So if we look this by country here, we can see the increase in hot days, which is above what's called the 95th percentile of the temperature distribution. So basically, what are the top 5% hottest days in the year, and how many of those will you see in the future? You can see there are some really significant increases in those hot days across the region, with some countries more than others. And if we then look at how does this express itself in just temperature-based heat. So we see that northern Vietnam, the Mekong Delta, eastern Sumatra, southern Borneo, and Java are particular hotspots through the scenarios of future thresholds. So the projected higher temperature increases in Indochina, and as well as much more hotter days over the maritime continent, will become a fact under especially the high emission scenario in the future. So the figure on the right there again shows the percentage of hotter days across the different countries. So the bars represent the spread across those 6 models that we downscale. So this is for us the key indication of the uncertainties of the projected changes. How does it translate it into some of the impact? So let's have a look at regional sea level rise first. Now, I just want to emphasize that looking at sea level rise at a particular location is a very complex structure and science to look at, because you've got global processes that contribute to sea level rise, that you add regional processes like the change in the dynamics of the sea level. What are the key currents doing in the Southeast Asian region, for example, plus some of the key local processes such as tide surges, but in particular vertical land motion. So vertical land motion can be very, very different just 100 kilometers away, and it's very different in urban location versus non-urban locations. So you actually have to look at global, regional, and local processes separately. IPCC does that in their methodology, and then you have to combine the distributions of those changes in a specific way to reach to your local sea level. So in Singapore, actually, the sea level rise at the tide gauges is quite similar to the global average, and will reach around 74 centimeters by the end of this century, and somewhat higher by 2150, so up to 1.15 meters. And a lot of the tide gauges in the regions are quite similar, except those that where we already saw significant vertical land motion, i.e. sinking in the historical period. So these are the examples of our analysis across Southeast Asia, and you can see, for example, that significant high sea level rises you see in cities like Bangkok and Manila. What about heat? So I showed you this before about the just temperature 95th percentile, the top 5% changes. So how does that translate to the change in future heat waves? So if we take one of the standard definitions of what's a heat wave here, which is 3 consecutive days where the daily maximum temperature exceeds that 95th percentile of local temperatures. So here we look at the region, and you can clearly see the increase increases in the frequency of the heat waves, the duration, as well as the magnitude, with specific hotspots across the region. We have so much data on this, so I'm just showing you the broad regional picture. We're also doing a lot of the specific by country analysis, and we hope to provide more detailed country-specific information on our portal soon. Now, this is probably the first CMIP6 or IPCC AI6 based analysis of WBGT, the wet bulb globe temperature over the region, based on our 8-kilometer data. And on the left-hand side, you can see the country averages for the 3 different scenario, and for the high emission scenario on the right-hand side, the changes in WBGT in Southeast Asia. Now, WBGT, there's a few definitions around, especially some of those so-called simplifications. This is not the simplification. This is actually running an offline energy balance model to use the outputs from the model to calculate the true WBGT as it's defined. So the problem with WBGT, such as it is with lots of other variables, is if you want to look at specific thresholds, you have to bias correct your data for impact studies. And to bias correct data, you need good observations across Southeast Asia. So one of the things we're doing right now is, because we also downscaled ERA 5, the reanalysis to 8-kilometer over a 50-year period, and we can use ERA 5 reanalysis to bias correct our WBGT assessment, and thereby actually can look at real thresholds of WBGT in future time slices. So this is ongoing work right now, but this is very unique information. Some of the other work, and I just provide a quick picture of this, is we're looking at other impacts and food security is very specific, as Singapore, for example, imports most of their food. So an example would be rice from Thailand, which is one of the key import countries. So therefore, how climate change is impacting rice production in Thailand would be of significant interest to Singapore. Having an 8-kilometer data set, we can actually look really district by district and understand things like temperature threshold in the different phases of the rice cycle, and how this might impact on the overall yield in the region. This is just scratching the surface. The data set can be used for many such impact studies. One of them is dengue, what we call dengue climate sustainability. And so this is not looking at actual dengue cases. This is just asking the question: what is that future climate niche for the 2 dengue mosquito types, and how is climate change changing this geospatial niche in future? And so we looked at the various scenarios, understanding where the occurrence of those 2 dengue mosquitoes would spread further across Southeast Asia. All our information is available on the data visualization portal, which is the QR code on the top, and this includes the reports that we produced, the videos and brochures, all other supporting material, but in particular an interactive interface where you can play around with some of the visuals. The data part will come probably within the next 4 to 6 weeks and will come live. Thank you very much. I hope this provided some good information for you.
Thank you, Dr. Moise. If you could kindly take a seat on the left-hand side. So again, we now open the floor to any questions. You can scan the QR code to go into the pigeonhole, so you can post your questions there. We also have mic runners as well this time around as well, so if you would like to raise your hands, you can also do so. Perhaps an initial question from me while we wait for the pigeonhole questions to come in. You've talked at length about some of these V3 projections. Perhaps you can also discuss how these V3 projections will be used to implement policy and change.
So actually, before we even started the study, we had a really intense consultation with our stakeholders, which mostly are the different Singapore government agencies. And our key question is what it is their need and how to help them refresh their policies in whether it's adaptation or otherwise. So we are connected to most ministries and agencies, and before, throughout, and especially after, had a lot of engagement with everyone. So our results and the information that we produced is helping URA to understand things on future urban Singapore. It helps the Ministry of National Development, especially PUB. So PUB, the water agency, who's building the Singapore's protection against sea level rise, they had access to our information before we even finished the study, because they were interested in updating their latest design parameters, basically. Yeah. So we are very well connected to the path to impact for the Singapore government, and we hope that this can be sort of repeated in the region. So we're happy. We already provided our data to, say, Brunei. They're building a climate change information service for their country based on our data. We are collaborating with the Philippines, and we're trying to find as many collaborators as possible who are interested in using our data.
All right, thank you. And I think that answers the first question we have here on how to use these findings to support policy making. So perhaps a different question. Are there any efforts to incorporate medical data into these climate projections to understand current and future health impacts?
Yeah, so with any impacts, you have to provide the link between the physical and the sector-specific information. We are not experts in this, and so that's why I'm calling on those experts to reach out to us, and we're happy to provide that link. I think in these projects you need to have the knowledge base from both sides coming together. But we won't be able to do the medical analysis, but we're happy to link up with this. Yeah.
Maybe a partnership will be
Absolutely.
Splendid in this sense. So the next question. The future warming scenarios look so severe, especially in SSP5 8.5. Is it too pessimistic? And what is the most probable future climate change scenario you would suggest policymakers should prepare for?
I think there's no standard answer to this because in the end there has to be a risk assessment, a very broad risk assessment by every country that then comes up with a decision on where they look. And we heard earlier already about Singapore is an island. We don't have a lot of options here. So I think the strongest, most risk-averse analysis is needed here. And this is why the Singapore government is committed to use SSP 585 as their main scenario to inform their decision-making as far as I understand. But that doesn't mean that every country has to do the same thing, of course. And there's a big sort of a more and more growing science community in the Working Group 1 science that says maybe SSP 585 is already unlikely because of the commitments through the net zero and NDCs that the pledges that country are making. We're likely to end up below SSP 585. That doesn't mean there's no need to look at SSP 585, but the reality is that we may end up below this, so not the 5-degree change, luckily.
That would be great, but also I think it's also important to think about policies to solve the worst case scenario so that we are better prepared for if something better comes along. Perhaps another question. We expect some degree of adaptation, allowing for greater tolerance to heat stressors as temperatures rise. Is there a need for revised WBGT temperature model or alternate measurement systems?
So WBGT is meant to relate to the physical heat stress in humans, right? That's not going to change quickly. I mean, we're not going to change as humans so quickly to need a different heat assessment. So I don't think that WBGT will change. What may change is a better understanding of what heat is doing physiological to our body. And I do believe that there is a need to separate dry and humid heat waves, to understand the differences in the different latitude bands, and especially the humid heat waves in Singapore. So I'm really looking forward to further work with Jason on his results on the physiology and understanding how this relates to the physical measurements of WBGT.
All right, thank you. So this question relates a little bit to Professor Chow's discussion just now. This is regarding climate risk, which involves key petals like vulnerability and exposure as well. The data available tends to be seen as mean temperature, which doesn't seem to account for exposure and vulnerability. How would you get around this? A tough one, I think.
Yes. So data availability is always an issue for analysis that you do, and this is why ending up with mean temperature is not a surprise to this. We have in Southeast Asia there's a big issue with sharing with data and data availability to do analysis across the entire region. So in the end, I think it needs to be addressed within each of the countries first, and then shared across. I think this is why we are making our data set available to others. We're not really asking for them to share the data with us. We are saying use our data, bring your own data, and then we can work together.
Yeah, a collaborative effort across the board for sure. Any questions from the floor so that Dr. Moise can get a drink, perhaps? Just a little bit. Oh, thank you very much, Professor Ren Chow. Do I have my mic runners at the front? Thank you.
Thank you, Dr. Moise. Just curious about the temperature fluctuation situation, whether this kind of projection models, they can capture this feature. Because based on Hong Kong observatories weather record, recently we observed this kind of temperature fluctuations. That means the extreme can go to really extreme case. So just wonder whether you can do this for this region simulations. Thank you.
Yeah, so not sure what I understand what you're talking about those high extreme temperature fluctuations. So maybe we can pick this up in the break. I'd really like to understand. So we actually collaborating with Hong Kong. We are very interested in, so I should maybe say it before this. Aside from those projections I just spoke about, we are also running a 100-meter urban model and to understand the future urban heat island effect. And we are collaborating with Hong Kong, interested also in looking at this really high-resolution future projections. And maybe this is something that can be picked up, so I'd like to understand more about what it is you're talking about. Thanks.
All right, maybe one final question from the Pigeonhole, which is, have you factored urban climate and built environments when you run these simulations and projections?
Not in our 8-kilometer or 2-kilometer downscaling, and this is sort of a model intrinsic thing and this is why we decided to now run our 100-meter urban model. And so what you do is you take the 2-kilometer downscale data and you use that data to force the 100-meter model on the edge and thereby get a really great understanding of what will happen. Now the problem with urban heat island and future climate change is there's one parameter is the change of the climate in the city, but an equally as big parameter is how will the city change in the future. So what will Singapore or any big city look like in 50 years' time or so? That because urban morphology is one of the key inputs in modeling urban climate and driving urban heat. So as we have the future climate information at high resolution, we need to discuss with the planning agencies such as URA and in other cities to understand what are their scenarios for the planning into the future, because that will have a key impact on what the urban heat island looks like in the future.
All right, with that, we've come to the end of the session. Let's put our hands together again to thank Dr. Moise. Thank you.